Welcome back. In this lecture, we'll study about normalization. Why normalization is important? Suppose we might have a quantum state which is not normalized. So if we perform our quantum operation with a non-normalized state, then there will be an error in our output. So to tackle that, we need to learn normalization. We need to normalize the vectors or quantum states. Okay. Before directly going into the normalization, we'll first try to understand norm. Sorry. What does it mean? It means norm is the length of vectors. Okay. Now, suppose to identify the length of a vector, the formula is, suppose we are having a vector u. Okay, let's take vector a. The normalization formula is square root of inverse of vector a dot product of vector a. If you find this value, then it is the length of our vector a. Looks something different and difficult, but when you really apply this and solve a numerical, it looks very easy. Okay, to make it simple, I'll take an example and solve it. Let's take an example with vector u. Vector u have 2 and 4i, and vector v have -1, 3i, I. Okay. Now, if I need to find the length of vector u, what is the formula? Sorry, here the small correction. The notation should be like this. This is the notation to find the length of a vector. Okay. So to find the vector length of a vector u, how we can write? Equal to square root of inverse of u vector and dot product, that is should be dot product with u vector. So to find this, what is the inverse of u? It is 2 minus 4i. Why minus 4i? If you don't understand the minus 4i, it is very difficult. So please go back and watch my previous video where I explained the conjugate works and how the inverse of vector works. What does the imaginary numbers play? Okay. Now we can simply substitute here 2 minus 4i into, what is the vector u? 2, 4i. So 2 into 2 plus minus 4i into 4i. Correct, right? Is this true? Then it will be 4 plus, calculating minus 4i into 4i is little tricky. So to make it easy and comfortable and very easy to understand, first you need to understand the imaginary root values. What is the value of I? Square root of -1. So if I need to find I square, what will be? Square and root will get cancelled, so it will be -1. Now I cube, since I cube can be written as I square into I, so we already know the I square value, -1, so into I. What is I cube minus I? Okay. Now it will be plus into minus is minus 16 I square. Correct. But we know that what is the value of I square? minus 1. So you can write as root plus minus 16 into minus 1. So it will be root of 4 plus minus into minus plus 16. That equal to, what will be the answer? Root 20. That is, we can write it in 2 root 5. Correct? Okay. Now, similarly, solve for vector v. Consider this as homework. Okay? Consider this as homework problem. Solve this. Now, we'll go deeper into normalization. Okay? A quantum state is normalized if its lengths are equal to 1. That means if the length of quantum state, length of quantum, what happened to this? Sorry for the disturbance. Length of quantum state is equal to 1. Then we can consider that the quantum state is normalized. This can be written as, let's say we are having a quantum state psi, so length will be, that means inverse of state with respect to the quantum state should be equal to 1. If this condition is satisfied, we can tell that our quantum state is normalized. Okay? Now, why normalization? This ensures that when measuring a qubit, the probabilities of obtaining bit 0 and bit b is equal to 1. So this is why the normalization is important. Okay? First, we'll understand the process of normalization, like how to find the normalization. Okay? Process. Let's say we are having a unnormalized quantum state. Unnormalized quantum state. Okay, that is, we'll take psi alpha ground state plus beta excited state. If you are new and not knowing about the ground state and excited state, go back and refer my previous videos. I have explained over there. And the second step is find normalizing factor n, which means that is equal to 1 by square root of alpha square plus beta square. Okay, remember this formula. It is very important to find the normalization factor value. Now, third step. Multiply the states, that is multiply with our normalization factor. So n into, what is the state, quantum state? Alpha ground state plus beta excited state. So this is our final normalized quantum state. If you solve this, you will get an new quantum state that is called as normalized quantum state. So we'll take an example. Okay, let's take we are having an unnormalized qubit psi 3 ground state plus 4i excited state. Okay, so what is the first step? We need to find the normalizing factor n. So n equal to 1 by square root of alpha square plus beta square. But how to identify alpha and beta? We know that quantum state will be in a form of psi alpha ground state plus beta excited state. So if you observe closely this both equations, our alpha value is 3 and beta value is 4i, correct? So now simply substitute the values. 1 by square root of 3 square plus 4i square. Now it will be 1 by square root of 9 plus 16. We'll get 1 by square root of 25. What is the square root of 25? It's 1 by 5. So we got our normalizing factor n. So how to find the normalized state? What is the formula? Psi normalized state is n should be multiplied with our quantum state. What is our quantum state? 3 ground state plus 4i excited state. 3 ground state plus 4i excited state. Okay, substitute the n value. 1 by 5 into 3 ground state plus 4i excited state. Okay, what will be the final answer? 3 by 5 ground state plus 4i by 5 excited state. So our quantum state is successfully normalized. That's all for the day. In next lecture, I will explain about the logical gates and the quantum gates. Until then, subscribe my channel, watch the content. It's quite interesting about the quantum gates. So that's it for the day. Solve the homework problem. See you guys in next video. Thanks for watching.